Greetings for the day, sir. Uh, Today we are discussing about a project titled Stock and AI, leveraging deep learning and NLP for sentiment-based stock prediction. So our project members are Sai Varun Kadavoina and myself, Nidish Manne. So getting into the introduction part. In this project, we focused on leveraging natural languaging process, especially Finbert, to analyze financial news and set 10K filings. These filings provide deep insights into a company's performances and risks, but analyzing them manually is inefficient. By automating sentiment extraction and combining it with traditional stock market indicators, we aim to enhance stock price prediction accuracy and provide meaningful insights for investors. Coming to the background, the US SEC mandates public companies to file annual reports called 10Ks. These contain detailed narrative about the business risks and financials. Analysis traditionally go through them manually, which is slow and often subjective input. A domain specific NLP model is designed for sentiment classification in financial text and offers a powerful way to automate the process effectively. So, coming to the problem statement, uh, manual sentiment analysis of financial documents is not only time intensive but also varies based on the reader's interpretation. Financial language is complex and filled with jargon. Our goal is to automate sentiment extraction from these documents using Finbert and combine that with stock price data to build a more holistic data driven prediction system. So the methodology, our methodology starts with the data collection, which we fetch 10K filings using the SecEdgar, SecEdgar API by querying with the company CIK numbers. These filings are downloaded in HTML in HTML format. We also collect historical stock price data for the same companies. In pre-processing, we clean the HTML file using beautiful soap and regular expressions. We strip out scripts, styles, and irrelevant sections to retain meaningful content for sentimental analysis. Uh, and uh, and once the data is cleaned, we run it through Finbert due to the model input size limitations. We chunk the text into manageable sections. Finbert classifies each chunk into positive, neutral, or negative sentiment, and we aggregate these scores by section. For price prediction, we combine these sentiment scores with historical financial data and train deep learning models like LSTM or GRU to predict future trends in the stock prices. So, coming to the experiments, we applied our pipeline to multiple companies' 10K filings. We extracted sentiment for sections like MD and A and risk factors and compared sentiment patterns between companies. This allowed us to observe how sentiment varies year over year and across industries. We generated and visualize sentiment distribution to understand the tone conveyed in each report. So the discussions were like the sentiment analysis clearly highlights the tone of different sections. For instance, black factors tends to show more negative sentiment compared to the business overview. Finbert was quite effective in dealing with financial technology and long form text. However, we did encounter challenges like token size limitations and long processing times and ensuring context was preserved while breaking the text into chunks. So, coming to the conclusion part, Okay, so coming to the tech stack, uh, our implementation was entirely in Python. We used requests for fetching data, beautiful soap for HTML parsing, pandas and regex for data processing, and hugging face transformers library to use Finbert. The sentiment analysis model was run using PyTorch. The integration of all these tools allowed us to build an efficient and extensible sentiment analysis system tailored for financial documents. So, for the conclusion, we demonstrated a complete pipeline for from retrieving 10K filings to performing sentiment analysis using Finbit. This forms the foundation for future work in integrating sentiment signals with stock market prediction models. Moving forward, we aim to expand the analysis across multiple years and add more financial indicators such as earnings and visualize the insights via interactive dashboards. So, coming to the contribution for of team members, Sai Varun Kadavoina implemented the Finbird based sentiment analysis pipeline, and he built the data for the processing workflow using Beautiful Soap and regex as we discussed, integrated sentiment scores with historical data for analysis, and contributed to report writing and result interpretation. As far as myself, I've worked on developing and automate the SEC 10K data retrieval using the Edgar API, and processed and cleaned the 10K filings for sentiment extraction, and worked on merging stock market data with sentiment sites, and prepared visualizing and supported project documentation. So that's it for us. Thank you.
Thank you.